Okay, good morning, people. Sorry to have delayed the broadcast. Just give me some time. I'll just get the PPT going. Yeah. Mayuri, good morning. Swapnil, good morning. Sneha, good morning. Avikshit, good morning. Sushil, good morning. Avi, good morning. Saloni, good morning. Gauri, good morning. What is Prathamesh saying? Which topics are given to assignment because I missed some lectures? You can visit the earlier lectures on YouTube and you can get an idea of that. And of course, we have been discussing it on our WhatsApp group also. Prathamesh, by the way. Karthik, good morning. Mrunmai, good morning. Prathamesh, good morning. Sakshi, good morning. That's all I have for the day, I suppose. Yeah, where were we yesterday? I'll just, before I go to the session today, a few things that I would like to bring to your notice. Anjali, good morning. That our today's lecture is not going to be the full stretch, that is 11 o'clock, because if you have seen on the group as well, that the Vada Sabha is organizing a workshop for students as far as public speaking is concerned. And while the Vada Sabha members are going to attend it on Google Meet, the official channel, others can obviously, Isha, good morning. The others can use the YouTube link which is given towards the base of that particular notice, and you can see that. It's going to be today and tomorrow, 11 to 12:30 today. We are going to have Siddhanath Ganu, who is a news reporter for BBC Marathi. He is a Vada Sabha member also of 2011 batch, and he is going to speak on how to be presentable in front of the camera, and other aspects as such, because many a times because we are looking into an abstract lens, we tend to be less emotional, uh, and obviously news readers are those who are very much into that day in and day out. So we thought that he should be speaking to you all. And tomorrow we have one more guest speaker who's going to speak on the content and time management and so on and so forth. So all of y'all are invited to this particular talk that's going to be starting at around 11 o'clock. And that's why I will be ending my lecture. Prajakta, good morning. I would be ending my lecture at around 10:45. Okay. So that's one thing that I wanted to mention. And by next week, next Thursday, for sure, we need to shift to G Suits. So just in case anybody is still left, as I told you that even if you have not got your credentials, it's better that you log in with your credentials. But unfortunately, if you have not been able to secure your credentials as of today, we could accommodate you in that particular lecture without your credentials also till you get your credentials as such. So that is another thing that I wanted to mention here. I actually I wanted to start it today itself, but since as I think day before I was to get a bit late. Okay, and in fact you see that I started at 10:03 instead of 10 o'clock. I skipped it because I could not go into all those details while I was in college as such. So I planned it. I shifted my plan and I've planned it for the next Thursday. We'll at least start. How far can we be skeptical as to we need to get all the students and so on and so forth. As a consequence, let us give it a start next Thursday and see how it is going to run. Now, don't worry, because I would be recording those lectures also. Don't worry, in the sense, those students who are not able to connect at this particular time, we are going to record those lectures, and I'm going to post it on my channel as well. As far as possible, I'm going to try to post it on YouTube also, in case students would like to join from YouTube. Now, of course, our regular students would have to join it through the proper channel using the credentials as such. If those who are not have those who have not received their credentials can surely attend this on from the YouTube channel also. Okay, so I'm working on that, and by next Thursday, this should be operational as such. Okay. Secondly, today morning I have posted you a few notes as far as the cycle of erosion is concerned, and you could go through that, and we could discuss on that also. In fact, we have already started discussion on that, and I would go into that right away, sharing the screen for the same. And if you remember this yesterday, I spoke to you about the anatomy of a drainage system. And when we are looking at the anatomy of a drainage system, we have three views of a river. Okay. Uh, I was reading through the notes before I posted those notes to you, printed notes to you. I was reading through them. And the reason why W.M. Davis speaks about the river extensively is basically because of the fact that he finds the river to be a universal thing. If he had started speaking about glaciers, we know that in the tropical and the equatorial regions we will not have glaciers. Okay, so there could be countries which would not have a coastline, so waves are out of question. There could be countries which would not have wind based landforms. So he found out that river is something which is very, very universal, and as a consequence he planned his cycle of erosion using river as an agent of erosion. So all diagrams, coming back to all those diagrams which we tend to see as far as rivers are concerned, they have to be viewed in three aspects. A diagram could be a cross section of a river. Say, for example, when we speak about a V-shaped valley, or a U-shaped valley, or a trough-shaped valley as such, we are actually looking at the cross section of the river as such. Okay. When I'm looking at a river from the top view, this is going to be called as the plan view of the river. You'll see that the diagram to the left of your screen is something which could be called as a plan view. Now, plan views could be different. You'll see that they could be absolutely perpendicular, they could be at an angle. Now, to get the best sense of natural features, normally you will see that perpendicular angles are not that suitable. In fact, it has to be inclined. Any angle, you'll see that as far as shooting is concerned, natural shooting is concerned, you'll see that the cameras are always at an angle. So, for example, we were watching the Home documentary the other day. You'll see that the angles were at a 45-degree. The angles of the camera was at a 45-degree angle as such. So they give you the best feel because of the illumination and the angles of the illumination. The best feel is got at around 45. Of course, the timing is also very important. It is believed that normally morning 10 o'clock onwards is the best time as far as getting photographs is concerned. 12 o'clock onwards, it is still there, but you'll see that the reflections, they are going to be a bit difficult. Again, you shift to the evening around 2:30 to 4:30 could be the best time for aerial photography, as it is called. Coming to the photo, say the slide in front of you, you'll see that a river, say a river which carries all the water, okay, is can be divided or can be demarcated with what is called as a drainage divide or a watershed as such. I did speak about it the other day also, that all water falling within that line, colored line, which has been posted all around the river, all the water is going to be drained through the main river in that particular area. That's called as the catchment area. It's very simple. You'll see that the area catches the water, and that is why it is called as the catchment area. Once the water is caught, you'll see that it will move through tributaries and the main river, and of course in the process is going to cause erosional features. It's going to be causing transportation, and of course it's going to cause a lot of depositional features also. When I'm looking at the river sideways, okay, I spoke about the V shape, U shape, and trough shape. When I'm looking at the river from the front, when I'm looking at the river sideways, I would be plotting what is called as a longitudinal profile. Okay, so at times longitudinal profiles are important and put to use. At times cross profiles, as they are called, are put to use. And of course, as far as explanation of processes is concerned, a plan view, okay, on it, or an aerial view at an angle, of course, is comes to be very handy as such. Okay, let us move ahead. And just like we started yesterday, I'll just revise a few things. Okay, the ideal stream cycle, as such, W.M. Davies speaks about this. He is supposed to have given. Now there is a bit of variation as far as the time is concerned. I believe he the I have the reference here with me, and the year that we have referred to in the, it's 1899. Okay, so it's 10 years what beyond what is written here as such. So it was in 1899. Probably this there was, you have this before that also, but the theory may have not been established absolutely. So the year when it is probably established absolutely is 1899. Okay, yeah, and it measures, it reads in the text as in a well-developed form as such, called as the geographical cycle. Okay, and he says that every river passes through a youth stage, a maturity stage, an old stage, and of course after that you're going to have rejuvenation. Now, what does he mean when he is referring to a youthful stage as such? Okay, a youthful stage is a valley. Now, remember, these are geometric figures, but they are very much representative as such. You're going to have V-shaped valleys, and it's in these processes that the water which is going to pass through these V-shaped valleys could fall off rapids, would fall off waterfalls. They certainly are not going to cause floodplains, because you'll see that the base of the valley is tapering. For a floodplain to develop, okay, either now this V shape has to be filled with something, that's siltation, and it is on that siltation that you would be having the floodplain and the meandering and oxbows, etc., to form. But we all know that at this particular stage, the energy with the river is so huge that it does not allow anything to settle down in that V as such. Okay, or let me put it this way. Okay, you'll see that the V is very, very clear. In fact, the water keeps on cutting in this particular V. As a consequence, you don't have sedimentation. Because you don't have sedimentation, you're not going to have a floodplain as such. On the other hand, when we come towards the upper edges of the say the V shape, you will see that the two V-shaped valleys could be separated by flat tops, flat topped broad drainage divides as such. These are undissected by erosion. Now, of course, this is not always true. If you go to the Himalayan rivers, you'll see that most of the, because the Himalayas are a fresh and a new mountain range, it could be a result of that you could have crested tops also. uh, it could be because of the relief also, the highest point and the lowest point as such. Okay, we are to discuss about that in detail maybe next time as such. Okay, you'll see that the valley is continuously being deepened. Okay, you'll see that the major activity towards the upper course is deepening of this particular valley. It opens up down, 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 and you'll see that the V starts get steeper and steeper and steeper as such. Okay, so this is the general agreement, of course. And as far as the features in this particular phase is concerned, yesterday we spoke about, and of course it's written here, rapids and waterfalls. In the course, you'll see that you have some things which are called as potholes. Okay, you'll see that at the base, if it's a rocky surface, you'll see that the water drills into that particular rocky surface, and it develops hollows like pots, and that is why these are called as potholes also as such. Depending on the size of the river, depending on the energy of the river, the potholes could be of varied sizes and shapes also as such. Besides that, I can't think of any particular more features here as such. Then we come to the second thing, early maturity. What has happened is the V has opened wide, you'll see, and the crest is sharpening. Okay, the crest is sharpening while the V is started to getting blunt as such. V-shaped valleys, and you'll have beginning of floodplains here. You're going to have sandbars and sand gravels, which are going to be lying here and there. And you'll see that in the earlier picture, while the river was significantly straight, what you can see is in this picture, the river, particularly the second one, it has started meandering. Okay, if of course it's not an absolute meander, but it has actually say it has started to meander, you could say so, as such. Okay, the relief is reaching maximum. Now there is one diagram on, you could write this for your benefit. You'll see that there is one diagram on page number 304. If I have given you the pages as well, otherwise it's say approximately the fourth sheet, which discusses how the changes in the relief occur as far as this whole process of cycle of erosion is concerned. Now, why have the valleys opened up? We spoke about this yesterday also, that the valleys have stopped deepening. And that is why you'll see that what was a very steep V is now opening up into a very broad V as such. Okay, you'll see that erosion is on the decline here, and settling, okay, is settling of water, and of course sedimentation has started in this particular stage. Thus, we move to the late maturity stage. You'll see that there is a significant development over and above the early maturity stage as such. Now, what is this particular change? You'll see that the V has remained the same. Okay, now there could be an disillusion amongst the students with this particular diagram. I don't want you all to look into the old age diagram. This is the diagram to the extreme left as such. Remember that the shape of the valley now is not looking like a V. Okay, or it is a V which does not have a base as such. Now, why has that particular thing happened? The diagram should be corrected in the sense that it is still a V. It is still a V, but you'll see that this base of the V is now being settled down with a lot of siltation. You'll see that a lot of sediment has come up in both the valleys as such. Okay, so you'll see that has filled the valley, and now the energy is not there with the water as such, and that is why it allows the siltation, and that is why you'll see that the shape now goes into a trough shape rather than a steep V shape as such. Okay, and that gives the river a very broad channel to move, and thus you'll see that it is within this sedimented channel that the river keeps on moving here and there. And what is going to happen as an eventual outcome of that is we're going to see in the old age as such. What are the characteristics of late maturity stage? The valley has a flat bottom. Okay, yes, the floodplain is narrow. Okay, of course, we are going to see a much larger floodplain when we're going to move to the old age stage also. As such. Okay, the divides begin to round off. Okay, what was a very cresty and a very sharp divide is now getting to get rounded off as such. The relief diminishes. You'll see that the highest point and the lowest point of that particular terrain, that particular area, has reduced. What is relief? Relief is basically the difference of a particular region between the highest point and the lowest point. You'll see that the relief in the Himalayas is very high. The relief in the Aravalis is low. What does that mean? That the highest point in the Aravalis and the lowest point in the Aravalis is lesser in difference as compared to the Himalayas. Say, for example, when we are speaking about the Himalayas, the average height could be starting at around 800 meters, the base of the Himalayas. And of course, we know that Mount Everest is 8,800, and now what 48.86 is what is being discussed. But you'll see that the difference in the lowest and the highest point along the Himalayas is nearly 8,000 meters. So this is a very high relief. As this gap narrows, the relief is going to get lower and lower. Okay, so that is something which is not actually immediately translated through diagrams, and that needs to be told by the teacher during the lecture as such. Okay, and because of this, now you'll see that in what we saw here is that the river hardly had any scope to move here and there. In the youthful stage, the river did not have any scope to move here and there. But you'll see that in the late maturity stage, the river has claimed a lot of a playground for itself, and that is why it plays around that particular floodplain. And this playing around that particular floodplain is now going to be the initiation of meandering. Okay, so this is late maturity, and we have to understand early maturity and late maturity together. Let me tell you that as such. Then, as far as old age is concerned, you'll see that here what was an open V now is in fact further, it's a trough shape. It's no longer a V as such, and you'll see that the floodplains have gone very very large here as such, and in this it becomes a very huge playground for that particular river, and you'll see that it curves and bends and curves and bends, and it forms very very significant meanders as such, and it leaves behind features which are called as oxbow lakes also. In between, you see, for example, here, this is one mound here, and this is a mound which we are supposed to understand it has been cut as far as the diagram is concerned. These are resistant rocks. These are resistant rocks, and these are hard rocks which stay behind, and that is why they are called as erosional remnants. Okay, they don't go down faster, and that's why they are called as erosional remnants. Because say the Monadnock's name comes from a local hill in a particular region that uh, Davis was referring to. Okay, so and another characteristic feature of the rivers meander across extremely wide flat floodplains as such. The relief also has come down now because these are geometric. You'll see that we are not able to actually measure the relief, but if we are to see actual photographs, then we would be in a position to understand. Just for example, if I am to give you an example of how and where we are supposed to understand the various levels of the river Ganga. I would say that from its origin, okay, that's Gomukh all the way to Rishikesh. Okay, from Gomukh to Rishikesh is the first stage of the river Ganga. And in this area, you would form the Ganga behaving in this particular way, the youthful stage of Ganga. Then you'll see that as far as this immediately below Rishikesh, the Ganga starts getting this way. And while it goes towards Allahabad, by the time it reaches Allahabad, you'll see that the Ganga, of course, is much broader than this, but this is how it would look. And beyond Allahabad, through Bihar and further, you'll see that this is what the Ganga would be. So within one stretch, you can identify the three stages of a particular river. In fact, that is one of the criticisms that this guy Davis had to face over the period of time. And we are going to speak about the um, criticisms in detail, because unless and until we know the criticisms, we cannot speak about the limitations of that particular theory as such. But before we go into the other slides as such, what is important to understand is that he speaks about a term called as rejuvenation. Rejuvenation, if you look into say for its meaning into what is called as in a dictionary as such, you would be able to the explanation that comes out of rejuvenation as a term is the fact that something is reborn as such. Okay, but as far as Davis is concerned, rejuvenation, he means that some changes cause streams to speed up and cut deeper. Now, why does this happen? This could happen because of three major things. Okay, upliftment of land, lowering of the sea level. Upliftment of land and lowering of the sea level, both of them would be because of tectonic movements or endogenetic movements as such. It could be because of folding, it could be because of faulting, it could be because of a volcanic eruption in that particular area, it could be because of an earthquake which happens in a particular area. So all upliftment are related to that. Lowering of the sea level also could be. Now lowering of sea levels would have two connotations, I would rather say. Lowering of sea level could be because of tectonic movements, one. Lowering of sea levels also could be because of what do you think the second cause of lowering of sea level would be? Yes, climate change could be the second reason why there could be a lowering in the sea level as such. So either ways, if there is going to be a lowering of sea level, now why is the sea level so very important when we speak about it in the whole cycle? With regards Davis or without regards Davis, you'll see that it tends to be a very important aspect, because remember that the base level, where did that every drop of water that is flowing through the rivers, where did it move from? It has moved from say it has, rather I would say, evaporated from the sea surfaces. So the sea surface is supposed to be, the sea level is supposed to be the base level of erosion, and that is why you'll see that this whole process will end only when that drop comes to the original place where it started from, isn't it? And that is why sea level is very sensitive. If the sea level rises, the whole scenario changes. If the sea level falls, the whole scenario changes as such. And then you have the third aspect, that is the greater stream flow. Again, greater stream flow would have two connotations. One would be because of heavy rainfall for a particular season as such. Another one is, which is, I would say, not exactly tectonic, but I would say it is more related to human activities as such. Now, what exactly do I mean when I say human activities? You'll see that nowadays, in the present scenario, human beings have constructed a lot of dams in across rivers as such, and the greater stream flow would be release of water through these dams as such. So that is how. And that is why the stream flow could increase, and this increased stream flow could alter the equations as far as erosion and deposition is concerned as such. The next point is stream valley takes a youthful characteristics but remains features of older stages as well. So with rejuvenation you could have combinations. Okay. And rejuvenation can happen at any point in the cycle as such. So that is as far as the Daviesian cycle is concerned. A few more things that we need to understand out of these Daviesian cycles and are being projected here. Okay, this is how rejuvenation. You'll see that the earlier slide, okay, the last slide was basically this top was the base of that. But now what has happened is that the top is further raised because there is an upliftment of a landscape from beneath. So you'll see that what was beneath now comes to the top, and the whole process again starts. And thus you'll see that if you have not observed here, just look into the shape of this valley now. It is not a single V, it is V in V. It's a V in V. I would rather say a V in a trough again, a V in a trough. So you could see that the first cut here is the level of the first base level, and then there is a rejuvenation, and then it is going to go down further as such. And you'll see that while these were the initial monadnocks, okay, in the new feature you have new monadnocks which are coming up, and the river is basically meandering around these monadnocks after that. So that is rejuvenation of a land of an old landscape as such. Okay, rejuvenation of an early mature landscape. Now unfortunately you'll see that a major criticism of what Davis was referring to is the fact that he says that the whole process completes and then rejuvenation takes place. Now, of course, he corrected it afterwards, but this is still considered as a criticism against this guy Davis, that it's not always the nature is not going to wait for the river to come down to the basic level and then go for rejuvenation through tectonic activities. Tectonic activities could happen anyway. Okay, you can read in fact that in the notes that I've passed to you, that it could happen in an early mature shape also. So thus you'll see that now you have this is a V in a V. Okay, so you'll see that it has gone up till down till here, and suddenly you'll see that it rises up. So you're going to have a cut line here which will indicate that this was the earlier level and now it is further down here. Of course, this doesn't happen overnight. This takes hundreds of years to happen, but okay, this is what research tells us. Okay, now let me see if we have anything more. Yeah, these are a few cycles in arid erosion cycle, and of course this is the maturity of arid erosion cycle. Now arid basically means dry. Okay, and what we need to understand here is with regards steeper slopes, and of course old age is you're going to have Inselbergs, Palaya lakes, and Pediplain, not a part of your syllabus as such. Yeah, there are a few things that we need to understand as far as the dynamics of a river is concerned. What are the terms that we need to understand if we really need to study the river as such? The shape of the channel is one. The slope of the channel, which is also called as the gradient. The volume of the water that is going to move through this channel, that's called as discharge, and the velocity with which the water moves. Now the velocity obviously is going to be dependent on the shape one, and the slope also. Okay, and the volume. So you'll see that velocity is a dependent characteristic. And I'm going to come to capacity and competence, but let us see how we are looking into this as such. Now this is the increase and this is the drainage area. Okay, This shade is the headwaters, that's the upper stream. This is the midstream, and this is of course the lower stream as such. I am sorry, I have to enlarge this a bit for you all. Now let us see if we are able to. You'll see that the slope. Now, if you have to speak about the slope, you'll see that the slope is very steep in the headwaters, that is the upper course, and then it gets gentle in the middle course, and it gets very, very gentle as far as the lower course is concerned. As far as bed material and grain size is concerned, you'll see that in the upper courses you'll find huge rocks and boulders, but by the time you come to the mid level, the rocks and the boulder size gets very low. In fact, you'll see that this is steeper as compared to this, and in fact this is more gentle. So you're going to get very, very fine material as you move towards the older stage as such. Okay, the mean velocity flow, this is the mean velocity. You'll see that the velocity again is very, very high in the earlier stages. It goes down significantly. In fact, there is a drop. If you see, the steepness is moved into a gentle curve, so the velocity is going to drop down significantly here, and towards the lower course there is hardly any change as far as the mean velocity is concerned. It is, you'll see that it really is nearly is running parallel to the x-axis. So you'll see that there is not much change as far as velocity is concerned. It keeps on moving along with it as such. Now the channel depth, what can you say about the channel depth? You'll see that the channel depth is I think it's there's some problem as far as the channel depth is concerned. I'll come back to that. But the channel width is concerned, you'll see that the channel width is very narrow in the earlier upper courses, and then gradually it starts opening and opening and opening, and by the time it comes to the latter stage, the channel is hugely wide. But here again we have to see the three differences. You'll see that the change in the channel width is very fast in the upper courses. This reduces in the middle course, and there is hardly any change. For miles together, the width of the river is going to remain as it is as far as the latter course is concerned. This is how we tend to read this particular diagram as such. Okay, the relative volume of stored alluvium. So you'll see that as far alluvium basically meaning the deposits. Okay, you'll see that in the upper course the rivers are sharp V-shape basically because nothing stays there, everything is washed off. But you'll see that as you enter the middle course, the upper middle course, the early maturity, you'll see that still it keeps on pushing, but the late maturity, you'll see that the material starts depositing. And as far as the latter stage is concerned, there is a significant amount of rise as far as the volume of the stored alluvium is concerned. Now, coming to this interesting concept of capacity and competence. Okay, I would first ask you to think about what actually these words mean to you in the general sense. Then we'll bring it to the river sense of it. Capacity of a river and the competence of a river. Before this, let us say that the capacity of a person and competence of a person as okay. You see that capacity basically means ability, and competence means the best ability as such. Okay, you'll see that if you say that okay, I'll give this work to this particular person, can he have that does he have the capacity? You would say yes, he has the capacity. Does he have the competence? We'll have to see. Now competence depends on the skill, competence depends on your education. Say for example, it's out of capacity for every other individual to medically treat patients, but a doctor is a competent person to treat medical ailments. Okay, so that is the basic difference between capacity and competence. If you have not understood the difference in the so-called what to say, the dictionary sense, let us go to the river and try to understand it. Let me see if I have yeah, you'll see that this would be the best slide to explain capacity and competence as such. Okay, you'll see that if you see here, I'll just enlarge it here. Okay, you'll see different types of material in suspension, in solution, in traction, and saltation. If you remember, I spoke about these terms yesterday, that smaller the size, with the change in size, you'll see that there is a change in the name. Okay, some material is dissolved, solution. Some material is fine, but it does not get dissolved, so it moves in suspension. Some material is small, but it cannot remain in suspension. As a consequence, it keeps on jumping and moving ahead. That is called as saltation. But the larger one, they are literally dragged and rolled along the riverbed as such. So transportation takes place in four things. Now, if now just imagine, if you are looking at, if you are imagining the earlier slide and the curves of movement, you'll see that if it was the upper course, now even this could have been in saltation. May not the size will not take it to suspension, but this will move to this, and saltation will go into suspension. And if the suspended material is soluble, that could go into this. Now why has this happened? Basically because the energy of the river has increased. When does the energy of the river increase? It increases in various, the volume increases, the gradient increases, the slope increases, the water is going to move faster, so the velocity is going to increase as such. The moment velocity increases, these things would move in and descending order, in the sense things in traction could go into saltation, things in saltation could go into suspension, and things in suspension could possibly go into solution as such. This is called as the competence. Okay, for now, say for example, in the monsoon season, the competence of the river increases. The river remains the same, but in monsoon the competence of the river increases, basically because the amount of water that the river is now carrying during the monsoon, it increases, so the energy increases. So it would push something into traction, which was something which was in traction in summer, it will now go into saltation as far as in monsoon is concerned, and what was in saltation in summer will go into suspension as far as monsoon is concerned. That is why you see that monsoon waters tend to be very muddy, okay, because it picks up as far as the competence is concerned. Capacity, on the other hand, is how much water it is going to take. It's not related to how fast, how much in volume, etc. It's the capacity basically means that if this is the shape of the river, the capacity of the river is going to be carrying water to the full through this particular shape of the channel is concerned. But you'll see that the competence, though the capacity remains the same, the competence could change because of various things happening, in the sense the volume of the river increases, the velocity of the river increases, and so on and so forth. So these are a few things that these are basic things basically when we are to identify the difference between capacity and competence as such. As I said, I'm not going to take you for long. This slide on river transport, etc., and the keywords in transportation and various features. These are the three main slides which we are supposed to be doing, and this is understanding all the so-called agents of erosion in detail. I'll explain this graph. I specially prepared it for the understanding of students, so we'll look into it later. We'll stop here for now, and as I said, next Thursday, 99.99% will meet on G Suits, and having met on that, we would be continuing with river transport then as such. So that's all for right now. I'll just end this, and I'll come back to this. And yeah, uh, if you have any questions on what we have been doing till now, you could very well ask your questions here as such. Don't forget, sorry, don't forget that in some time from now, that is 11 o'clock, the Vad Sabha is going to conduct a workshop. And this workshop is going to be about public speaking, the timing, facing the camera, and so on and so forth. Yeah, I'm still waiting for questions. If you have your questions, you could very well post your questions to me. I have, as I've already said earlier, also I've already posted notes as far as the cycle of erosion is concerned. I have see, this one was that, and you could go through that. If you have any questions, you could just write down your questions and ask me when we would be meeting next time as such. So if you don't have any further questions, just check if anyone has any posted any question. No questions as of now. uh, I'm still waiting for if you have any questions as such. By the way, I was just watching BBC yesterday, and it connected that we were watching the movie Home. You'll see that how things have been different. Just check on Google as far as news is concerned. This snow problem in Tokyo. That there has been a traffic jam which has gone because of the snowfall in Tokyo, outskirts of Tokyo, of course, wherein the traffic jams are extending into tens of kilometers as such. People are in a country like Japan and in a city like Tokyo, okay, because of a natural hazard like snow, It's not a snowfall. It's a snow. I would rather say it's a snowfall. It's not a storm. It's just a fall, but it has been accumulating, and people have been caught on roads for 2 days. And the Japanese government is working very intensively. Now, this is what is happening in the Eastern Hemisphere. As far as the Western Hemisphere is concerned, I forget the name of the country. Very recently, say these are the islands. One of the islands, as far as South the Caribbean Sea is concerned, very recently a storm has struck there, and they were showing this on parallel context, in the sense the snowfall in Japan and this tropical cyclone, as far as the Caribbean Sea is concerned. Remember, that is the southern hemispheric part as such, and of course, Japan is in the northern hemisphere. You could go into the details of trying to understand what is what in detail what has happened there as such. By the way, as always, thank you very much for being there. Don't forget to join the Vada Sabha workshop at 11 o'clock on YouTube. A link given in the group as such. Stay home, stay safe. I will be ending my broadcast now.